Find the solution set of the following inequality. We have got x minus 2 over 2x minus 3 is greater than or equal to x. I've always been saying always, for inequalities, you are not allowed to cross multiply. So since you are not allowed, we are going to get x, we take it the other side, becomes negative x, that will be greater than or equal to 0. Okay, from here, please don't merge this. This don't extend the fraction. Okay, you are going to make the question become, you would have changed the question, and obviously all the solving is going to be wrong. So we are going to say this is over 1. We are going to make this as a single fraction. What is on top of the first fraction multiply with what is down the second fraction, that will be x minus 2. What is down the first fraction multiply with what is on top of the second fraction. So that is 2x minus 3 multiplied by negative x. That will be negative 2x squared, and then positive 3x. And then multiply what is down the two fractions. So that will just be 2x minus 3. That will be greater than or equal to 0. So on top, add like terms. You are going to have, I'll start with the negative 2x squared, and then positive x plus 3x, that is going to be positive 4x. And then we have got a negative 2. In the denominator, we're going to have 2x minus 3. That will be greater than or equal to 0. Get what is on top, equate it to 0, and also get what is down, equate it to 0. Negative 2x squared plus 4x minus 2 is equal to 0. So the product here, negative 2 times negative 2, positive 4. The sum, positive 4. Vope, what are the factors? What two numbers can we multiply to get 4? When we add them, we get 4.
Positive 2.
Mm-hmm.
2 to positive numbers of 2.
Okay, so positive 2, positive 2. So this will become negative 2x squared plus 2x plus 2x minus 2 being equal to 0. So this becomes negative 2x, open brackets, x minus 1. And then we're going to factorize out a 2 here, open brackets, x minus 1 equal to 0. Meaning we're going to have negative 2x plus 2, and then x minus 1 being equal to 0. So what are we going to find? Equate each to 0. You are going to find that x is equal to 1, or this negative 2x plus 2 is equal to 0. I'll take the 2 the other side. So that is going to be negative 2x is equal to negative 2. We're going to find that x uh, is still equal to 1. Okay, so that is how it's going to be. So basically that is just the same solution. Okay, and then equate also this other one in the denominator to 0. So we're going to find that 2x minus 3 is equal to 0. You are going to find that x is going to be equal to 3 over 2. So basically you only have two solutions, 3 over 2 and x is equal to uh, 1. And I've seen this question was trick. Okay, so what we are going to do is we're now going to get the solutions that we've gotten. We are going to make a number line. So the first one, I'm going to put it like this, another one like that. So we have got 1, and then we have got 3 over 2. I'm saying like this question was trick, because people would get it wrong because you've got the same, you found the same value for the same for different points. So people would neglect one point. So remember, what did we equate to 0? We equated to 0 first, x minus 1. Okay. We also equated to 0, negative 2x plus 2. Others would leave out this because they know it gave them the same answer. We also equated to 0, 2x minus 3. Remember, we are dividing here, so we're going to be interested also in their quotient. So let me clean up this space. Please, even if it is the same factor, like you have got x minus 2 squared is greater than 0, which you can also write as x minus 2 greater than 0. If you want to find the solution set, equate this to 0, you are going to get 2. Equate this to 0, also going to get 2. Even if you found the same value, but when you're writing a number line, you've just found x is equal to 2. But write them twice, okay? You're going to write x minus 2, also write x minus 2, and then they're multiplying, also find their product. If you don't do that, you're going to get it wrong. Now, from here, what we're going to do is, remember, when we equated, x minus 1 to 0, we found positive 1. So if I use values of x greater than positive 1, what do we expect to have? What do we expect to have if I use values of x greater than 1? Are they positive values or negative values? If I get a 2, I put in this equation x minus 1 where there is x. What are we supposed to have? Positive or negative? Positive. Okay, so that will be positive. Then if I cross the 1, it becomes negative. And then negative 2x plus 2, we, we equated to 0, also found 1. So what happens if I use a value of x greater than 1? For example, I get a 2. I put where there is x. What are we going to get? Negative or positive? What are we going to get? Vope, what will we get?
Uh, First, before I answer, the figures are too squeezed. Is that negative 2x minus 2 or plus 2? So they are going to be positive figures.
So you mean if I get a 2, I put here, I'm going to find a positive figure.
Oh, where? Hmm?
So it will become,
Oh,
it will
no,
be
you get
negative.
negative. So,
So immediately I cross the 1, that will become positive. When we equated 2x minus 3 to 0, we found 3 over 2. Use any first, let me use anything that is less than 3 over 2, like a 0. A 0 is the simplest. I put there. It will be negative, meaning that immediately I cross 3 over 2, it becomes positive. So negative, positive, negative, that is positive. Positive, negative, negative, that is also positive. Okay, positive, negative, positive, that is a negative. But we want where x is greater than or equal to 0, meaning that it is starting from here going in this direction. Now, if you see in the denominator, we've got 2x minus 3, meaning that even if this is greater than or equal to, we can't include 3 over 2 because if we include 3 over 2, we put in the denominator, we're going to get a 0. So meaning that we're going to use an open circle here instead of shaded. Okay. So you can see that the solution set is equal to negative infinity up to what? Up to 3 over 2. And we are not supposed to include 3 over 2. So it will be like that. So that is how we're going to write it. You can just try to prove, get any number above 3 over 2. Any, like above 3 over 2. For example, a 2 is greater than 3 over 2. Try to put in this equation. So that will be 2 minus 2 over 2 times 2 down there. That is going to be 4 minus 3. That will be a 1. Will be greater than or equal to. Put again where there's x, you put a 2. Is 0 greater than or equal to 2? This is not true. So you've seen anything that you're going to use this side is not going to work. It is not going to work. And then you can try anything which is less than 1, like a 0. Just for confirmation sake, if what we are doing was correct. You can get a 0, come and put in this function. So that will be 0 minus 2, which is negative 2, divided by 0. 2 times 0, that is 0, minus 3, that's negative 3, greater than or equal to 0. So negative 2 over negative 3, that's negative 2 over 3. I mean, it becomes positive 2 over 3. Is that greater than or equal to 0? We know this is true. So this region has worked. You can also try out any number between 1 and 3 over 2. It will also work. So that is how you're able to show, to just confirm what you are doing is correct. But if you know what you are doing is correct, it's better you get to confirm after. Okay, after you are done. Otherwise, you might waste time just confirming and confirming on a question because you don't have the a lot of time in the exam. Do you have any questions on this question? All right, we are going to go to B. Evaluate the limit. We have got a limit as x approaches 2 of x cubed minus 8 over x squared minus 4. Now, if you go direct, you substitute where there is x. You are going to get on top 0, down 0. 0 over 0, you don't want to have that. So what you are going to do is you are supposed to factorize this one. So you are going to write it also as limit as x approaches to x squared minus x cubed minus 2 cubed. Like 8 is the same as 2 cubed. So write it as a difference of 2 cubes. And then down you're going to have x squared minus 2 squared, the difference of 2 squares. So this is going to be limit as x approaches 2. Whenever you are writing the difference of cubes, okay, difference of 2 cubes, this is always, you get a first number, that's the x. In other words, if you've got a cubed minus b cubed, this is going to give you a minus b. Then you are going to have a squared plus ab plus b squared. That's how you write it. So the a is the same number that is raised to the power 3. So in this case, it's x. So I'm just going to write x minus. The b is the same number that is cubed, that is a 2. And then you write again the a, but square it. Now in this case, a is x. So x squared. Then plus multiply the a and the b. The a is x, b is 2. So that will be 2x. And then get b, you square it. B in this case is 2. 2 squared is a 4. Then divide that by the difference of two squares. We know that it is x minus 2, x plus 2. So this and this cancels. And then we're going to go on direct and substitute. Where there is x, we put 2. That will be 2 squared plus 2 multiplied by 2 plus 4. And then divided by 2 plus 2. Basically, what we have on top is 4 plus 4 plus 4, which is 12, divided by 4, and that gives us the 3. Any question? Are we good? The class is going to be boring the way you people are quiet. It's bad.
I'm okay on my side. I have a question.
Yes.
Is there any other way of working out the numerator?
No. That's the only way. When you've got a difference of two cubes, you need to know that way. It's the only way to factorize out that. Okay, so the other one down, we have got the limit as x approaches infinity for 2x cubed plus 1 divided by 2 plus x minus 3x cubed. Now, when you're talking about limits to infinity, you just look at the power on top, the highest power on top, and the highest power down. If they are the same, just get the coefficients. Like the coefficient of the highest power on top is a 2, coefficient of the highest power down is a negative 3, meaning that this is going to be the limit 2 over negative 3. But just to show that, going to say limit as x approaches infinity, the highest power is the 3, so divide everything by x power 3. So 2x power 3 divided by x power 3, that will just be 2. And then 1 divided by x power 3. Okay, in the denominator also divide by x power 3, that will be 2 over x power 3 plus x divided by x power 3, that will be 1 over x power 2 minus the 3x power 3 over x power 3, that will just be 3. And then at every point we are saying x put infinity. Immediately you substitute infinity, the thing limit goes. That will be 2 plus 1 over infinity cubed divided by 2 over infinity cubed plus 1 over infinity squared minus 3. Any number over infinity, whether infinity cubed, whether infinity squared, whether infinity is 0. So this is 0, this is 0, this is 0. So all you have remained with is a 2 over negative 3, which is basically negative 2 over 3. So that is it also. Just a moment, there is a network problem. All right. So we are now on question C. I hope you got part 2, how to find the limit. But if you didn't get, please you can get to follow up the tutorial video. You're going to see it. Question C. So for x in the equation, 2 to the power 2x plus 1 is equal to 3 2 to the power x minus 1. Now, when you're solving exponential functions, if you can't make the bases the same, the next option you have is substituting a certain letter for a certain exponent. And most of the times it will be clear. Like you can see you have got 2 to the power x, meaning that where they're supposed to be 2 to the power x, you're supposed to substitute an exponent, a certain letter to represent that exponent. So I'm going to break. When you've got 2 to the power 2x plus 1, we can as well write this as 2 to the power 2x multiplied by 2 to the power 1. Like you had same bases which were multiplying, so you added the powers. And this is equal to 3 2 to the power x minus 1. Okay, so I can as well write this as 2, and then instead of writing to the power 2x, I'm going to first write x, and then I write 2 like that. Okay, I've just rewritten this term which is here. That's the one you're able to see down there. And then this 2 which was here, I'm going to put it outside. So that 2, I'm going to put it here. And then that is equal to 3, 2 to the power x minus 1. Chibuya, is this okay? Hope even if you've just joined, is this clear?
Yes, it is.
Okay, so where there is 2 to the power x, we are going to substitute. So I'm going to say let b be equal to 2 to the power x. So this is going to be 2. Where there's 2 to the power x, we are going to put b. But remember it is squared. And then that is supposed to be, I'm going to take this term this side. It becomes negative 3. And then where there's 2 to the power x, I'll put p, right? I mean b. Oh, the audio is cutting. I'm going to put b, and then I'm going to get this negative 1. Take the other side, it becomes positive 1. And that is going to be equal to 0. So this is the equation that we are going to have. Frida, is my network cutting?
Yes.
Like you can't clearly get me.
Oh, sorry. I was really distracted. I can get you.
All right. So what we have now, we are going to find the product and the sum. Product is a positive 2, sum is negative 3. Wope, what are the factors?
Negative 1 is the negative 2.
Okay, negative 1 and negative 2. So I'll start with the 2 since I've got a 2, then plus 1 at the end. We'll factorize out 2b, so that will be b minus 1, then negative 1, b minus 1 is equal to 0. So giving us 2b minus 1, b minus 1 being equal to 0. So we're going to have, if I equate this to 0, I'm going to find that b is equal to 1 over 2. Or if I equate the other one to 0, I'm going to find that b is equal to 1. But remember, okay, 2 to the power x is equal to b, meaning that 2 to the power x is equal to 1 over 2, or 2 to the power x is equal to 1. So this 1 over 2, if the 2 I take it on top, it is going to become 2 to the power negative 1. Or 2 to the power x is equal to 1 is the same as 2 to the power 0. You just need to write the same bases. Mean that x is equal to negative 1 or x is equal to 0. So these are the values of x. I don't know if you guys have gotten this. Is it
Personally, I have.
all right? Nice. Please be sure to ask. Like that's the only way you get to learn more and better. If it's not clear. Okay, so the next one, if xy is equal to 64 and log in base x of y plus log in base y of x is equal to 5 over 2, find x and y. We've been given log in base x of y plus log in base y of x is equal to 5 over 2. And then xy is equal to 64. We want to find y and x. The first thing that I'm going to do is I'm going to make the bases the same since we have got logs of different bases. So let me take all of them in base y. Okay, meaning that this is going to be log. I'm taking it to base y. But this term which is here, just copy it the same way it is. That's a y. And then divided by log, I'm taking to base y. And then what was the base here, now is what will become what will come here. So I've converted from base x to base y. And then plus log in base y of x. And that is 5 over 2. Are we okay with the conversion here? All right. Now, when you've got log of y in base y, that is a 1 over, we have got log in base y of x, and then plus log in base y of x, which is equal to 5 over 2. Again, I'll say let p be equal to log of x in base y. So this becomes 1 over, where there is log of x in base y, I'll put p and then plus p. That is going to be equal to 5 over 2. Okay, I'll make this as a single fraction. This is over 1. That will give us 1 plus p squared divided by p. That is going to be equal to 5 over 2. I'll cross multiply. We're going to get 2 plus 2p squared, and that is going to be equal to 5p. I'll take the 5p the other side, so we're going to have 2p squared minus 5p plus 2 equal to 0. So the product is 4. The sum is negative 1, negative 5. What are the factors? What are the factors?
-1, -4.
All right, -1 and -4. So we are going to come here, that will be 2p squared minus p minus 4p plus 2 is equal to 0. Meaning we are going to have p open brackets 2p minus 1, and then negative 2 open brackets 2p minus 1 is equal to 0. So we're going to have p minus 2, 2p minus 1 is equal to 0, meaning that we're going to have p being equal to 2 or p being equal to 1 over 2. Remember, but log in base y of x is equal to p, meaning that log of x in base y is going to be equal to 2, or log in base y of x is going to be 1 over 2. We are going to convert or express this one as an exponential function since it's a log. Okay, so this is going to become y is the base, so that will be y to the power 2 is equal to x. And then here, y is still the base, that will be y to the power half is equal to x. But remember, xy is equal to 64. I can make any the subject of the formula. Okay, let me make, let's say, x subject of the formula. So x is going to be 64 over y, right? This becomes y squared is equal to, where there is x, I'm going to put 64 over y, or y to the power half. Where there is x, I'll put 64 over y. So here we'll cross multiply. So be y to the power 3 is equal to 64. Or we'll also still cross multiply here, that will be y to the power 3 over 2 is equal to 64. Like when you multiply y to the power half times y, you're multiplying same bases, just add the powers half plus 1. Okay, to find y here, we're going to take the cube root this side and also this side. So y is going to be, what is the cube root of 64? That is a 4. And then to be able to solve this one here, since it is a fraction, like it is 3 over 2, power 3 over 2. So I'm going to multiply on top by 2 over 3. Also this side by 2 over 3, meaning that y is going to be 64 to the power 2 over 3, which also means that we have got a 3 down. Oh, sorry for that. We have got a 3 down, so that will be cube root. And then we are going to have 64 inside. And then the 2 which is on top squared. We know the cube root of 64 is a 4. And then squared, that will be 16. So y is equal to 4 or y is equal to 16. But what will be the value for x? Remember we said, what did we even make? We said that x, we made x up the formula and we said x was 64 over y. So when y is equal to 4, what will be x? X is going to be 64 over 4, which is what will be this? Okay, x will just be 64 over 4. I don't know what okay. 4 into 24, that is a 6. And then when y is equal to the other y value found is 16, then x is going to be 64 divided by 16. And how many times is that? 64 into 16, is it a 4? So that is going to be it for this question. Are we all right?
Yes.
Okay, the diagram below shows the shaded region R, which is surrounded by the curves with the equation y is equal to x squared and y is equal to 8 minus x squared. Find the area of R. Now, when you want to find the area between two curves, you want to find the area between two curves. The first thing is you are going to look at the equation giving you, like which is going up, and then you look at the equation which is going down, like having a minimum. Okay, so first look at that equation going up. So to find the area is actually an application of integration. So the area is going to be given as the integral of the equation which has got a maximum, which is x squared, minus the equation that has got a minimum, that is 8 minus x squared. Okay, and then we are going to say dx. Like every time you are differentiating, I mean integrating, you need to show with what respect are you integrating. That is with respect to x. That's why I've put dx. But we need to have the limit. So we need to know the upper limit and the lower limit. Like what's the x value where they're intersecting here and also here. That is why we first need to solve these two equations simultaneously. So since they're all equal to y, I'm just going to say x squared is equal to 8 minus x squared. I'll take x squared the other side, becomes 2x squared, and that will be equal to 8. And then both sides divide by 2, x squared is going to be equal to 4, meaning that x is equal to 2 or x is equal to negative 2. These are the limits. At times they are going to ask you to find the coordinates of the points where these are intersecting. So now we have found the x values. To find the y value, you'll just say y is equal to, if you, I'll use this equation since they are the same, it will be 2 squared, which is equal to 4. Even if you use negative 2 squared, it still give you 4, meaning that this coordinate here is negative 2 comma 4, and then this coordinate here is positive 2 comma 4. So we can also write the coordinates if they asked for such. Now that we have found the x values, we are only interested in the x values because we are using integration, and we are taking the x with respect to x. So the upper limit is positive 2, so the positive 2 I'm going to put it on top here. The lower limit is negative 2, I'm going to put it down there. So this is going to give us area being equal to the integral between 2 and negative 2 of, if I distribute this negative, this will be negative 8, this will be positive x squared. So this is positive x squared plus x squared, that will be 2x squared and then minus 8 dx. Now we can integrate. So the area is going to be, what's the integral of 2x squared? That will be 2x, add the 1 to the power, becomes 3, divide by the same, minus, if you integrate 8 with respect to x, just add an x. Okay, now the limits are going to change. The integral goes, now the limits, the upper limit will be here, the lower limit is going to be here. So to find the area, I'm going to substitute the upper limit, which is 2, that will be 2, open brackets, 2 to the power 3 divided by 3 minus 8, 2. Okay, and then always subtract as long as you have got a definite integral. And then I'll write it again 2, but where there is x, I'm going to put the lower limit, which was negative 2 to the power 3 over 3 minus 8 multiplied by negative 2. So this is going to give us 2 to the power 3 is 8 times 2, that is 16. So this is 16 over 3 minus 16. Then minus, same here, negative 2 to the power 3, but that is going to be negative 8 times 2, negative 16. Negative 16 over 3, negative 8 multiplied by negative 2, that is going to be positive 8. I mean positive 16. So I remove the brackets, it's going to be 16 over 3 minus 16, negative times this, it becomes positive 16 over 3, negatives times this, that becomes negative 16. Okay, like that. So this is going to be this one, we can add to this one. That is 16 plus 16, that will be 32, since the denominator is the same, over 3. Then 16 minus 16, that is also 32. Okay, negative 16 minus 16. I can say this is over 1. I multiply 1 times 32. Now this is giving me a negative area, and the area I'm supposed to find is supposed to be positive. Have I done the right thing? Okay, let me just review this. Maybe I've swapped, instead of writing, maybe we're supposed to start with this one and then we remove this one. And then I've done it the other way around. So that's the effect. If you get to 10 them, you are going to get it wrong. You are going to get a negative value instead of a positive value. But even if we've gotten a negative, I can easily change it. Okay, so when you are finding area between two curves, you first get the one which gives you maximum. Okay, the one which gives you maximum is going to give you the area down here, and then now you remove this area down here. That is what I forgot. Like, you remove that, then you're going to find the area between. So I was supposed to start with the one which gave me maximum, not starting with the one which gave minimum. Sorry for that. And we don't need to make that mistake. Hope it will not be made. So always start with the one giving you a maximum, like the graph having a maximum. Even when you have got lines, like you have got a line like this, you have got maybe a curve like this and a line like this. So it will be this one minus this line, because this one is more having a maximum. So if you have got something like this and then like this, start with this one because it has got more a maximum, and then minus this one, the curve. There's someone with a question?
Yes, sir. For me, I found the positive figure. I don't know if it's the right way.
Yeah, you start with the one giving you maximum, that is 8 minus x squared, and then minus the one giving you minimum. So the one giving us maximum is this one. You can see that's the one which goes on top. And then minus the one giving us a minimum. Now this is the one which goes down, which is the x squared. So if we simplify this, we're going to get 8 minus 2x squared dx. And then now we can integrate. That is going to be 8x minus 2x to the power 3 divided by 3. Now we can put the upper limit 2, lower limit negative 2. So the area now becomes, we get the upper limit, which is the 2. So that will be 8 multiplied by 2 minus 2, open brackets, 2 to the power 3 over 3. And then you always subtract, like always. And then you substitute the lower limit, that will be 8 negative 2 minus 2, that will be negative 2 to the power 3 divided by 3. So 8 by 2, that is a 16, minus 2 cubed, that is 8 times 2, 16 over 3, and then minus 8 times negative 2, negative 16. Okay, negative 2 to the power 3, that's negative 8, times this negative 2, that will be positive 16 over 3. So this is going to be 16 minus 16 over 3, and then plus 16 minus 16 over 3. Okay, 16 plus 16, that is a 32. So since we change the directions, and then negative 16 over 3 minus 16 over 3, that will be negative 32 over 3. So this is over 1. So multiply 3 times 32, that is going to give us 3 times 2, that is a 6, 3 times 3, that's a 9, and then minus 32 divided by 3. Meaning that the answer is now going to be 9 minus 3, is that a 6? And then 6 minus 2, that's a 4 over 3. So this is the area. But since it's area, you need to say 64 over 3, you put units. squared. Like area is always given in units squared. It can be centimeters squared, meters squared, whatsoever. Okay, are we good? Are we okay now?
Yes.
Okay, so we have got this question here. Sets. Given the sets A, which is negative 3 comma 2, B, which is 0 to 7, and then C, which is negative 5 to 1, and universal set U, which is from negative 10 to positive 10, find each of the following sets and represent them on a number line. The first one is A intersect B complement. So, as I've always been mentioning, when you've got things like this, okay, when you have got things like this, the first thing that you're supposed to do, look at the like represent on the number line. You are working with it on the number line. You have got the B complement, so I'm going to get B starting from 0 up to 7. Okay, now again, the first thing I think you need to put is the universal set, that is from negative 10 to positive 10, and just put circles there because the universal set is not including negative 10, it's not including positive 10. Now in the set B, we are moving from 0 to 7 and we're including both. So meaning that outside B, we're not going to include 0, we're not going to include 7. So we're going to just write that and then connect these lines. This is going to be B complement. And then you get now the set A, which is from negative 3 up to positive 2. We are not including negative 3, but we are including positive 2. So you can see that the intersection is going to be just here. So and shown a number line. So just shade this. You've shown a number line. Okay, that means A intersect B complement is from negative 3 up to 0. Negative 3 is not in the set A, so it can't be in the intersection. And then 0 is not in the set B complement, so it can't be in the intersection also. Okay, so that is going to be it. And then the next one, we want to find A minus B minus C complement. First thing first, simplify this one. Actually, just simplifying carries also marks. Okay, so you have got A, this minus B minus C complement. So I'm going to change this minus here to intersection. So that will be A intersection B minus C complement. But remember, if you change to complement, you need to bring another complement there. And you know complement cancels out. So that will be just A minus B minus C. Okay, and then what is inside there, also write it as A intersect B intersect C complement like that. So first thing first, I'm going to start with the C complement. First, write the universal set that is from negative 10 to positive 10. I'll just put circles there. Since I want C complement, the set C starting from negative 5 up to positive 1. But we want a complement. You see, negative 5 is part of the set C, meaning that it will not be part of the complement. 1 is not part of C, so it will be part of the complement. Okay, and then I'll connect this side. I'll also connect this side. This is C complement. And I need to intersect C complement with B. So I'll get the set B, which is moving from 0 up to 7. And we're including 0, we're also including 7. So the intersection of these two sets, we are able to see that it is this region from 1 up to 7. So we'll just get to shade that. Okay. Where this intersection now, we need to intersect it with the set A. What is the set A? From negative 3 up to 2. So I'll put that on another number line. So I'll just draw like this. Okay, the other one we found is moving from 1 up to 7. We can see 1 is included in both sets. Okay, so we're going to shade there. And then 7 is also included in both sets. So I'm also going to shade here. What set is this? This is B intersection C complement. Then we get the set A from negative 3 up to positive 2. We are not including negative 3, but we are including positive 2. Now we want also the intersection, so it is from here up to here. So we get to shade this region. So we see it is just 1 and 2 and we are including both. Are we okay with this? Friends, is this okay?
Yes. Yes.
Okay. Next question. Given that f of x is x plus 2, x minus x, sketch the graph of y is equal to 1 over f of x, indicating the turning points and asymptotes. So I want to sketch the graph of y is equal to f of x. But what is f of x? F of x is x plus 2 and then x minus 6. Now I want to also indicate the turning points and the asymptotes. The first ones we can find are the vertical asymptotes. Vertical meaning they are going up, meaning you are going to find them in terms of y, x. So equate the denominator to 0, x plus 2, and then x minus 6 is equal to 0, meaning that x is equal to negative 2 and x is equal to positive 6. These are the vertical asymptotes. Okay, the horizontal asymptotes, if you look at this question, okay, horizontal asymptote, if you look at it, like on top you have got a constant, down you have got uh, a letter x. So whenever you have got such a scenario where the denominator is heavier than the numerator, please, every time the denominator is heavier than the numerator, the horizontal asymptote is always at y is equal to 0. So because if I multiply down x times x, I'll get x squared. So it means on top, if I add something like 2x squared, the horizontal asymptote, I'll just get the number in front of the highest power divide by the number in front of the highest power down. That would be the horizontal asymptote. Now the turning point for this question, you need to differentiate. Okay, you need to differentiate. Since this is a rational function. So what I'm going to do is I'm going to cross multiply it down there. I've even changed on top here. It is just supposed to be a 1. Okay, so well, I'm going to write it as y is equal to 1 divided by the denominator multiply x times x, that will be x squared. X times negative 6, that will be negative 6x. 2 times x, that will be 2x. Negative 6x plus 2x to be negative 4x. Then 2 times negative 6, that will be negative 12. So to find the derivative dy over dx, we're going to use the quotient rule. So get the denominator the way it is, x squared minus 4x minus 12. Differentiate the numerator, we're going to get 0. Minus, I write the numerator, differentiate the denominator, that will just be 2x minus 4. Over, I write the denominator squared, that is x squared minus 4x minus 12. Now, at the turning point, the derivative, you need to know that it is equal to 0. Like you don't have gradient. So 0 is going to be equal to 0 times this is going to be 0. So I'm just going to have this negative times what is inside there. That to be negative 2x and then plus 4. Now this denominator will still multiply with a 0. So it will still be 0. So I'll not even write it. I'll take the 2x the other side. That will be 2x is equal to 4. So meaning that x is going to be equal to 2. This is the x value for the turning point. What we need to find again is the y value. To find the y value, go in the actual function. So y is equal to 1 divided by, I'll put where there is x, I'll put 2. So that will be 2 plus 2, which is 4, multiplied by 2 minus 6, which is negative 4. So meaning that the y value is y is equal to negative 1 over 16. So I write also here, turning point is at 2 comma negative 1 over 16. Please, you only use this if it is a rational function. If this was a quadratic function, how do you find the turning point? Hope, how do you find the turning point of a quadratic? I'm waiting.
Tab, my network was tripping. I hardly even know where you ended. It was on pause all along.
That's bad. Is it the case with everyone? Frida, did it also pause?
No, it did.
Okay, so we have found the vertical asymptotes and the horizontal asymptotes. Starting the vertical asymptotes, we have got x is equal to negative 2. So let's say negative 2 is here. And then x is equal to positive 6. Let's say 6 is here. So these are the asymptotes. I'm going to put lines like that on those points. And then the horizontal asymptote is y is equal to 0. Now you will not see like y is equal to 0 is the x-axis. And then the turning point is at 2 comma negative 1 over 6. So let's say 2 is here. Negative 1 over 6 is the number that is so close to 0. Okay, to be like very close to 0. So I can just show that is 2 comma negative 1 over 16. Okay, so you just get to label that one. That's how you show if you cannot write on the question that you have just shown, just label it. And then after then you can now easily draw. So the graph, what else have we been told? And indicating the turning point and asymptotes. Now, what happens when x is equal to 0? Okay, try to put x is equal to 0. Like put 0 here, that will just be a 2, right? Put a 0 here, that will be also a negative 6. So that will be 1 over negative 12. So the graph actually moves something like this, and then it will go like this. This is where it's going to 10, and then it starts going down like this. And then on top, it is also going to move like that. It will not touch those lines. And then it also move again like this. It will not touch this y-axis. I mean x-axis going up like that. So this is how the graph is going to move. So to see how it's going to move, you can just like get any value. You can just get any value between smaller than negative 2, you substitute in this function. But as long as you know that in this region the turning point is on the negative side, meaning that it's going to be down. Obviously it can't go up because you're not supposed to touch this asymptote. So meaning it's going to be coming down, and just this being down means that the others are going to be on top. Okay, from negative 2 it will be on top, from positive 6 it's also going to be on top.